Today we are about to continue with momentum and going to start up with law of conservation of momentum, that part. And here it is your new dude. This is going to be your new dude. Yeah, I am going to post it by tomorrow morning, not morning actually, tomorrow afternoon, because I have to go to school in the morning. I'll be posting this, and it is a speed post, mostly within like 3 days. You will probably getting it, because in this time there is no election, no anything. In the last time there was an election and it got really delayed. I don't think you will get it delayed for sure. If someone is closer to Nigambu, they can just come and collect it from our institute, even directly. If you are closer, because I can give it, because sometimes you don't get the postal delay if you come directly and get the tute collected. But here, this is the new one that is for the work, energy, and power. I am going to finish this lesson. I'm not going to start it even today, but next week I will start. In the very next week, I will finish. After, for 1 week, I will just completely do all the questions, including A-level questions. And now we can speed up. The reason is we have slowly done Newton's laws of motion until you to understand way better. Because that is the heart of physics, mechanics actually. If you understood the mechanics, Newton's law part, that means, and the force part, the rest of the lesson is going to be all depending on with the charisma of Newton's laws of motion. It is such a charismatic lesson. So you will receive this mostly by next 3 days of the time. Most probably, if it get delayed, because Sunday there will be no delivering of the posts. At least like Monday, Tuesday, you will definitely. Right? Okay, send me home addresses. I didn't open your messages. Right? And those who sent me the home address, I didn't open your message, all because of I wanted to keep it as a reminder and just post you the tute. Right? So everybody, if you have forgotten to send me the home address, send me, because sometimes the home address might have got changed. There are many things. I have many experience. I send the tute. They say like, sir, we are in a new location now. Then I had to resend it. Then the time was so far, they couldn't catch up some points. So, keys with you? Yeah, keys with me. So I need each time your address update for each time whenever I'm sending you the tute, because I'm not trusting any time about your previous address. Okay, that is the reason. So send me your home address if you didn't send me for this time. And Vimsat, are you there? Kanula Vimsat, are you there? Vimsat. Sanula නෑ වගේ නේ. නම Sanula සිංහල. Okay, students, if you are in abroad, so send me your home address of someone, your relative, or someone that he or she will collect the tute and send you. Today, I am going to start the law of conservation of momentum. Okay, law of conservation of momentum. Before that, I would like to remind you back again about momentum part and how the change of momentum occurred with these basic things, and what is the impulse little more, and directly go for momentum related final thing in the lesson, that is the law of conservation of momentum. Have a really good look at Firstly, I'm going to give you a reminder. If you absent in the last week, even if you were there in the class, sometimes you might need me to remind you because this is something easy, but kind of like tricky. Very easy, but tricky. So velocity. So the momentum is the product of mass and velocity, mv. This is what we got. And again, we had to find something called the change of momentum. So change of velocity. Okay, forget about change of momentum. Consider about change of velocity. It is moving at the velocity of u. After some time of t, it reached to certain velocity of v. The change of velocity is delta v. It is always v minus u. That means final velocity minus initial velocity. Like in the similar manner, in case of momentum, you have to do the same way to find out change of momentum in the way of P final minus P initial. Final minus initial. Something you may just remember. So here you can apply like mv for the final momentum, mv minus mu is equal to delta P. Sometimes you may have to use. So final and initial, always you have to consider about the change of direction. We talked a lot about this in the last week. I'm just reminding you the very basic only, not the deeper content. You have to watch the recording related to the last week because you may need this one to understand what I'm teaching you today. That is the law of conservation of momentum. Trickiest part in entire A-level physics syllabus, right? It will just run after you like ferocious snake as long as you will be doing physics as a subject, even in your university, everywhere, even in modern physics, nuclear, particle physics, everywhere, the moment change of momentum and the law of conservation of momentum will just attack you all the time. So don't let it attack you. Just start to play with it. That is what you have to do. So if imagine someone like a kickboxer come to beat you. If you are an inferior, you will get beaten. But if you are equal in the caliber of that mixed martial artist, what will you do? Come on, man. Then you will play with it. Understand the difference. You previous time he beats you. In this time, you are going to play with it. You are just sparring with the guy. He's just a play toy for you. So that is the level I am expecting you to master in this subject. Okay. Now the next point is we learned something like a bus moving with the velocity momentum of v. Okay. Now it crash. T equals to 0, it start to crash. Then this start to give some force of F1. Then the bus keep just continue to slam on it and now it is providing some F2. You are just mentioning about initial to time of delta T. So if it is like 1000 Newton at the beginning of the collision, at the end, at the middle point, it is like 10,000 Newton. Finally, again, like 1000 Newton. When it not, so you are going to get the average force. Imagine like the average force is like about 4000 Newton. We are not going to consider initial and final all. We consider like there is a 4000 Newton average force acting on it. Okay, 4000 Newton. And we have a time duration of the accident, like collision. Okay. So now we just need to find something called impulse. How are we going to find it? Impulse is equals to force into change of time. This is what we learned in the last week. Force into effected time. And we also found another thing. Impulse is none other than change of momentum delta m delta v. Then we could just merge these two equations. M delta v is equals to F delta t. Don't don't cancel off delta to delta. Hurry. Delta is not a part of the equation. It is just implying change. Change only. It is not something like y equals mx. So delta stands for just a change. So don't do this type of stupid things. Okay, don't do. So you have to leave delta as delta itself. Got it? Delta as itself. Delta stands for just a change. I hope you understood what we have done in the last 2 weeks of momentum part. Do I have to explain anything about it? Yes or no? If you couldn't participate to the class in the last week for any reason, I don't know, or if you were in the class but you couldn't understand, am I supposed to explain these things a little more, or shall I start the next part of the lesson? If you just need somewhat of more explanation, then I can, or just proceed with the new part, that of law of conservation of momentum. Tell me, what do you need? Next part. Okay, let's quickly start the next part. Okay. Now write. Big topic. The law of conservation of momentum. The law of conservation of momentum. Okay. Law of conservation of momentum. The first conservation law you are going to learn under this chapter is going to be the law of conservation of momentum. There are some people I have seen, they just teach law of conservation of momentum later after the kinetic energy and all, energy conservation. No need, you can understand. But only thing you can't understand is elastic and inelastic collision. That should be done after completion of law of conservation of energy. We have almost like 2 weeks to do that. Okay, so don't worry about it. Now write a very big topic, the law of conservation of momentum. The law of conservation of momentum. I think we didn't do that part so far. We didn't do that part so far, no? Did I do in the last moment in the last week? I think we skipped. No. Yes. Now write a big subtopic, the law of conservation of momentum. Hari. The law of conservation of momentum. Hari. And by the way, how about the paper last time? I fixed it in the evening time for you. So now I also thought like 1 o'clock is not user friendly, because I decided to give you like full enjoy time for the first half of the day. I decided to extend it again by 1 hour more. So it is mostly like we are going to plan to start it around 2 o'clock in the evening. How about it? 1 hodai the 2 hodai? Huh? 2 to 5 is my rescheduled time. How about it? Tell me in the Saturday. If anybody is really uncomfortable to join in that time, you can join as a record viewer. 2 is better, ne? Yeah, 2 is much better because you can enjoy the morning time to do something and come back home. Right? You can leave at 4:30, no problem. It is not a theory class, ne? It is not a theory class. You can leave, watch the last half an hour. Last half an hour as a record viewer. Right? मैं बाहर recording बंद हो गया हमारे ने. Yeah. Recording Okay. Have a look at it. Now write the law of conservation of momentum. There are some additional theory parts. We can just derive this equation from Newton's second law of motion, just drawing time graph and those. And it is completely out of syllabus, and I'm not going to mention anything about this force and time thingy. So it is useless completely. And so let's directly go for the exam value part, that about the law of conservation of momentum. These things are just a background theory. If you are really interested in only, I will make an additional recording for this extra theory. So I consider it as an extra theory. I will make a recording. I have, I think, even for the last year, I have the recording of that last year one or the new one I can provide you. If you need the additional information, not needed, not asking in the exams. But if there is someone who is just keen to learn those extra additional information, I can provide. It is not relevant to syllabus matter. So if someone is not actually interested in learning the deep core things, might not watch. So I will do it as an extra thingy. So now just directly go for the exam value of this one according to the equations and the formula and the concept. Or now write the definition of wheat with a hashtag or dollar sign, as you know that. Something like this, hashtag or dollar sign according to you. Now use when there is no external and unbalanced force. When there is no external and unbalanced force. External and unbalanced force. There is no external and unbalanced force applied on a system, you might think you are, sir, are you talking about Newton's first law? No, it is different. When there is no external and unbalanced force is applied on a system along certain direction of interest. අපි කැමති direction එකකට. Direction of interest. The object remaining, the system conserves momentum along that direction, along that particular direction. Okay. Have a good look at. Give me one second. Right. Now there is a mass which is just moving with velocity of 0 along that direction, this interested direction. Then what I'm doing? Last line, I can't remember what I said. I said like the momentum of the system remaining constant or conserved. You can write like conserved or constant along a interested direction. Okay. Right. Okay, this is what my interested direction. Now the velocity is 0. If the velocity is 0 along here, how about the momentum? M into 0. M into 0 means what? Then the momentum is going to be 0. Here the momentum is going to be 0. And if you don't apply an external and unbalanced force, it is something looks like Newton's first law. See, when there is no external and unbalanced force applying on a system, he said like the system remaining stationary or moving at constant velocity. That is completely right. Yes. So here I don't do anything. I don't do anything. No force acted in this direction. How about the momentum? The momentum will be remaining at zero. Right. Again, another system, mass of m and moving at velocity of 2 meters per second. M has a mass of like 10 kilogram. How about momentum of this system? How about momentum of this system? Okay, P is equals to 2 into 10. P is 20 Newton seconds. Newton seconds. I told you in the last week, we can write Newton second for momentum as well. Right. I don't apply any force. I don't apply any force. Nobody applies. So how about the system? Momentum of the system after 2 seconds. Nobody applies any external force. How about the momentum of the system after 2 seconds? It is conserved. It is conserved means it will be the same value, constant. 20 Newton second. After 2 seconds even 20. After 10 seconds even 20. After 100 seconds even 20. Why? There is no external unbalanced force. That's why. If you throw a cricket ball in the space, the ball has no other considerable force. The ball will be moving in the same direction with the velocity what you throw it at in a direct line, straight line. So the momentum will be conserved until it is getting external force of like a asteroid or black hole or any other object. If there is no object close by, the object will be moving at constant velocity. Understand? Yes, Nick? Constant velocity means constant momentum. Right. I told you the law of conservation of momentum. Right, Lamai? Let me show you one more thing. Now another thing. Another thing. How would you get here? Now this body is like 2 kilogram moving at 10 ms minus 1. This is a separate case. Now there is another object of like 4 kilogram only moving at 2 ms minus 1 here. After these two going to collide with each other. These two going to collide with each other. Okay. This is like 2 kilogram mass, 10 ms minus 1. 4 kilogram mass, 2 ms minus 1. These two are going to collide. What is the initial momentum of this one? What is the initial momentum of the system before collision? This one has a momentum. See, 20 kg ms minus 1. Kg ms minus 1. This one has 8 kg ms minus 1. Hurry. This is my positive direction. I will draw the line positive because I can't draw arrows to two different directions. But I can put a negative sign to here. What is the initial momentum? Can anybody tell me? I have already solved half of the question now. If you are wise enough, you can tell me. Very good, boy. Very good. How about it? Definitely. Definitely. What? Okay, how about look at P initial is equals to 20 here minus 8 here. P initial is 12 Newton seconds to the right hand side. To the right hand side. Now the problem is after collision. after these two collide with each other. How about the momentum? Tell me. How about the momentum after the collision? Tell me. What is the momentum? It will be the same. After the collision, it can have many multiple scenarios. Okay. I will tell you one by one later. So they can merge together and move the same direction like this. Okay. One stop, other move. One stop, other move. Other stop, this one move. In the same direction can. Oh, after the collision, like in a carom board, padinawa mehema හැරිලා යනවා. දෙපැත්තට. It can split like this. There are many possibilities. We are going to talk about each separately. Correct? You are done with that. But you have to remember one thing. Whatever the combination it can be, we don't care. But we know only one thing. If we had earlier momentum of 12, now the final momentum is to whatever the direction, we don't care. To the right hand side, definitely it should be 12 Newton second after the collision as well. After the collision as well, there should be a resultant momentum to the right hand side. Understand? Okay. Okay. Don't write anything. Don't worry. Now, I'm going to draw something. There is a certain object and another one. We separate these two by a spring. We learned spring theory. When we compress or extend, it will generate certain force according to like Kx. We learned 2 weeks back. Next, right. Now you just compress. After the compression, it is having a mass of like m1 here m2, and velocity of this one is 0. Velocity of this part is also 0. How about the initial momentum of the system? P initial of the system. For this part, m1 multiplied by 0. For the other part, m2 multiplied by 0. What is the initial momentum of the system? What is the initial momentum of the system? It is 0. It is 0. Okay. That is 0. Come on. That is 0. But the problem is, I am going to release this. මම මේක release කරනවා. මොනවා වෙයිද දන්නේ නැහැ නේ. After I release, what would happen? These two get separated. This one will move here like with m1 v1. This one move here like with m2 v2. Now tell me, what would be the momentum after I release these two? System. Momentum of the system after I release. Logic I'm asking a very big logic. What is the momentum of the system after I release? You can see one part moves to here, other part moves to here. See, so how about the final momentum? Tell me. Now it is very. I didn't ask anything about mathematical, just the simple idea, value. Vidusana, good girl. Vidusana, good girl. Vidusana is a good girl. Others? What? How is it? How is it? It should be 0, man. If initial is 0, this should also be 0. Final is also be 0. You might ask me, sir, no, there is the momentum of this part. I would say yes, m1 v1. Other one, there is a momentum of that part as well. M2 V2. Have a good look at this one. If this one is carrying like 10 Newton seconds to the left, that is my positive. Other one is carrying the force to exactly 180 apart, negative direction. If it is carrying negative 10 Newton second, how about it? 10 plus minus 10. The result is 0. That is how it gained final momentum of 0. නේද? ඔක තේරෙන්නේ නැතිනේ? නේද? I am pretty sure you understood it. Okay? I hope you understood it. නේද? Okay? Understood? Yeah. Okay. Now right. Along, I always consider the right hand side direction as positive here. Okay. Now along that direction it is conserved. That means initially there can be a zero momentum along this direction. But vertically upward, there can have what? There can have a momentum like this. It is accelerating upward, but horizontally it does not move. That means horizontal momentum is 0, but they can have a vertical momentum. Then don't consider about that right now. Now, right? According to the law of conservation of momentum, in a new line, according to the law of conservation of momentum, according to the law of conservation of momentum, momentum of the system, momentum of the system will be conserved along that direction. Now let's write examples. Now right, an object of mass 10 kilogram remaining at rest. Now right, an object of mass 10 kilogram which is remaining at rest, and there is no external and unbalanced force is applying on the object, right? There is no external and unbalanced force is applied on the object. Okay, right. Find out the initial momentum of the system. Along the right hand side, direction of right hand side, and final momentum after final momentum after 10 seconds. After 10 seconds. Okay, one. Okay, one. Pull on. Vinadi. Only 1 minute. Do it fast. How about this, Naman? How about this? 0. At the beginning, it is 0. At the end, also it is 0. P initial 10 times 0, that is 0. P final, that is also 0. How did I get that answer? How did I get that answer? According to law of conservation of momentum. Allopom. What is it? According to the law of conservation of momentum. When we add T also to here, according to the law of conservation of momentum at Allopom. According to the law of conservation of momentum, write in full words. Final momentum should also be 0. Otherwise, it will violate. It can violate. Yeah. About logo. About logo. According to the law of conservation of momentum at locum. At locum. Okay. You always need to mention this one when you do calculation. Huh? You don't understand? Okay, have a good look at it. Can you understand the initial momentum is 0? Can you understand this? 10 times 0 is 0. Okay. The law of conservation of momentum say if you don't, okay. Now this marker, if the marker has a mass of like 10 grams, reasonably. How about the velocity? Velocity is nearly 0. How about the momentum then? Momentum is also 0. Let's wait for another 5 seconds. 1, 2, 3, 4, 5. How the momentum now? Still 0. Another. Isn't that? Okay. Okay. How would you look at it? Now this marker, as I told you about 10 grams. Remaining stationary. Momentum of this one is about 0. Now it is not moving. Like let's wait for another 5 seconds. Initial momentum is 0. 1, 2, 3, 4, 5. After 5 seconds, how about the new momentum? What is the new momentum, Naman? Still 0. Still 0. 0. the momentum is still 0. Okay. Now I do something. I am going to now, I waited and nothing happens. I can't wait anymore. Then I punch this. You could see it move. And now it had momentum. What is the difference I made? Why did it move? Because I punched. Punch me. I applied an external unbalanced force on it. Can you understand? Unless external unbalanced force is given. Here, marker is just remaining stationary. That means no force, external unbalanced force is given. If I punch, that means external unbalanced force provided. It is a two different scenario. If no force given, the momentum does not change. Initially 0, finally it should also be 0. The reason is according to the law of conservation of momentum. Understood? Done? Finalized? Yeah, very good girl. Okay. Have a good look at it. Yeah, copy this. And I'm going to erase it. I will only give you 10 seconds. Now write a mass of 10 kilogram, initial, a mass of 10 kilogram is moving in the right hand side with an initial velocity of 4 meters per second. 4 meters per second. Have a good look. Final. Okay. Initial with 4 meters per second. If there is no external force applied, if there is no external unbalanced force is applied, right? If there is no external unbalanced force is applied. What can you say about the final momentum? All right. What is the final momentum? Then කියන්න බලන්න final momentum එක කීයද කියලා. Yes. Vidusana and Anuhas, very good. Loksan, very good. Now everybody seems to have understood it. Very good, very good. So initial momentum is 10 times 44, sorry. Initial is 40 kg ms minus 1. Hope you understand. Now here the thing is, I don't calculate anything. But I have a big weapon now. That I can use. So, okay. Have you ever played any computer games or mobile game or anything? Huh? Have you played any computer game or mobile game or anything? I'm not talking about snakes and thinking. It is a very different thing. Okay, Ramai? I'm not talking about that all the Nokia phone snake game. I'm talking about any game. Have you played any mobile game? Okay, I'm not talking about big gamer. I was not a big gamer. I used to play all the games like one day, then pro. දවසයි එල්ලම් කරන්නේ. එක දවසයි මම physical games වලට මම ආස නැහැ virtual games වලට. I don't like the virtual games because I always want to do a physical game. I normally try it, but to see what happens there. Each time in each game, when you keep playing, you get some scores. When you get the score, you can just buy certain things like in certain games, you can get like ammos. Ammos means guns and all. Then in the next step, you can just modify that gun. So like many options are there. So once you just in a new step, you have scored and collected some scores, then you can buy a new gun and you can use it and kill your enemies and score more. If it is a car racing thingy, then you can modify your car by just putting nitros tank and more, like many new facilities, new engine and all. Then each time when you in the new new level, you get new score. So according to that, you modify your vehicles or whatever the weapon with you. So we have a big weapon without doing any calculation, we can apply. So see how beautiful physics it is. Physics in a new lesson, you learn new thing. Wow. Then you can do the calculation. Neither? Yes. Then we have a weapon. What is the weapon? Hatlogom, what is it? According to the law of conservation of momentum, Hatlogom. We know the final momentum now. It is 40. How did we get this answer? We know that according to Newton, sorry, not Newton law. Law of conservation of momentum. Initial momentum should be equal to the final momentum. Understood? Say yes. Again. Yeah. Sorry. Okay, Ramai. Okay, and then. How come it be according to rain? There's no raining at here now. And it is also fiber connection. In a fiber connection, no problem with that. I do my class over here also because at my home there is no fiber connection because there is no fiber line nearby. I live like 2 kilometers from the main road. There is no fiber line. There is a fiber line, but from that point also my house is like located another 600 to 800 inside the village. There is no. It is like 600 to 800 meters. There's no line, so I will have to install my own lines and get the fiber connection. So it will be a very huge installation. Uselessly. So I decided to do the classes here now. Very lazy. But here also in the fiber connection, sometimes buffering. What to do? Now I have a good look at. Now right. According to the following system, Now I am not going to explain the nature. According to the what did you ask for it? Yeah. No, also you can do like self investment. So if I invest, the neighbors will get after that. අපේ ඉන්නේ එහෙම neighbors වනේ මම install කරනකන් ඉන්නවා line ටික ඒ ගාවට මේ නම. අන්න ඔක්කොම ගන්නවා. එහෙම set එකක් තමයි මේ it's Sri Lanka. Okay. Uh, according to the following system, find out the initial momentum and the final momentum after some time of delta t. Initial momentum and final momentum after some time of delta t. Okay. 10 kg, 2 ms minus 1. What is the mass I gave? It was 4. කලින් දුන්න වැලියකම දාන්න. It is again 2 ms minus 1. And the initial you want to calculate. Whatever happening with these two, we don't care. But only thing I need is P final. I don't care how it is moving, like merge together, one no stop, other move, both bounce back. We don't care. I only need the final value. Do it. By the way, students, I started to give this tube today, this time as a light color version. Because I continuously gave you dark color scheme. But in my physical class, girls didn't like it, boys liked it. I don't know why. All the boys like this, but the girls said like, Ane, we like the dark scheme. Let me know about your color preference. Color has nothing to do with it. But if it is giving you some kind of like more motivation while studying, so I can make a mix of tube, like dark color scheme and light color scheme. I can print any color, it doesn't matter. They will charge the same price. Only for the design, I will have to pay extra 1,000. That's it. That is not a problem. බලලා කියන්න dark scheme එකකට කැමති අය ඉන්නවා නම් I gave you dark series for a long time. Okay, initial. Have a good look at. To the right, I consider the positive as the right one. 10 times 2 here plus here what is about in a bracket 8 times 2 to there but with the negative sign because it is initially moving to the left. $20 minus 12. Sorry, not 8. Sorry. 4 times 8. The initial is 12 Newton second to the right. How about the final momentum now? That is 12. We have a big weapon that is called what? Law of conservation of momentum. ළමයි මේ අලුත් තියරි එකක් හම්බුනහම මේක ඇත්තටම වඩා උදව්වක් කරන්නේ. දකිද්දි හිතනවා අම්මෝ there is a theory called law of conservation of momentum. I have to remember this also. No man, it actually helps you. If you embrace it like that, it will definitely help you to do more calculations easier. Shall I give you more some kind of like hint? Copy this one, copy this one, copy this one. Okay. I'm going to erase. Okay. In the next week, we are going to learn something. No, next week, sometimes we can be. There will be a theory called law of conservation of energy. Okay. Normally, if there is a height like 20 meter, this inclined plane of like 30 degree, if you release certain object with no friction, you are asked to find out velocity of this one in the bottom. Oh, velocity. How would you find? In normal way? In normal way, how would you find the velocity of this mass? So if it is like 10 kilogram, okay, here 10 kilogram, no friction, initial velocity is 0, final velocity is asked. How would you do it? Just tell me, I'm not asking you an answer. How would you do it? You will mostly, I will do it. Do it like mg downward. You get like mg sine of theta. And ma is also downward. Ma, right. You will equal like ma equals to mg sine theta. M and M cancel off. A will be g sine theta. G sine 30. So that means it is 10 times half. It is like 5 ms minus 2. Okay. Now you apply it along. Then you will have to find out the velocity. You know, initial velocity 0, acceleration, you know, final. If you can apply like v square equals to u square plus 2as. But unfortunately, you don't know this. How would you find this? How would you find this? Now tell me, how would you find this? Is there any smart student? No, no. Yes. See, the triangle. This is the opposite side. Opposite side is 20. This is 30. This is something I don't know. We know that 20 over SC is equals to sine 30. How to get S? S equals to 20 over sine 30. S will be 20 divided by half. Mala harum 40 meters. Oh wow, now I know that. What would I do now? I would be doing it like v square equal to 0 plus 2 times 5 times 40. Then it is 400. V square equals to 400. V will be equals to 20 ms minus 1. Your answer was correct. Who did answer me? Yes, yes, yes. Very good. Yes. But the problem going to be after you learn law of conservation of energy, only 2 lines you will spend. You will spend only 2 lines. Okay, if anybody needs this, take a screenshot. Additional benefit. It is an additional thing. Okay. අමතර වාසි. මේවා නිකන් අමතරව හම්බෙත්ත නිකන් ඔය chance. කනා chance. It is an additional chance, okay? So now, if you know law of conservation of energy, you don't need any of this. You don't need any of these. You don't know any of this. Okay, mummy, put the pen in future. Next week, forecast. So, potential energy you will get like mgh. Here, according to the law of conservation of energy, you will learn that initial energy should be equal to the final energy. Don't worry, it will be a new lesson in the next week. You will learn like kinetic energy equals to half mv square. You can equal these two. mgh equals to half mv square. Capilla v square equals to 2gh. V equals to root 2gh. V will be equals to 2 times 10 times 20. Then your answer will be 20. Now tell me which one is easier. Now tell me which one is easier. Don't tell me whether you understood it or not. It is a new lesson to be taught in the next week. But after you learn in the next week, second method is very easy. Then තේරෙනවද අලුත් lesson එකක් කරද්දී අනේ අම්මෝ කියලා ගන්න එපා. Always take the new lesson, welcome the new lesson. Wow, what a wonderful කියලා. තේරෙනවද? What a wonderful කියලා ගන්න. Every time physics will be marvelous. ඔයාලා ජීවිතේට දන්නේ නැති දේවල් අලුතෙන් අම්මා. Okay. Forget about it. I only wanted to give you a message that each time when you learn something, that is a new weapon, that's a new tool. You can use it, you can enjoy it. Okay, done. Okay, Lamai, we learned that, we have done that. Now let's go for real world example. All right. An object of mass 10 kilogram, an object of mass 10 kilogram, which is moving in a straight horizontal path. Straight horizontal smooth path. Smooth. Moving in a straight horizontal smooth path. An object of mass 10 kilogram, which is moving on a straight, horizontal, smooth path. In a velocity of what? 4 meters per second. Meters per second. Directed towards a mass of an identical mass. Of 10 kg. And write this in a new line. After the collision, both objects merge together. They get set to now like this. Okay, now it got merged like this. Okay, merged and moved together. Find out the velocity of Yeah, second object at rest. Didn't I tell you about that? Second object is an initially at rest. Okay. Second object is initially at rest. If I didn't say that at that, find out the momentum of the merge object. Okay. This is at rest. Okay. This is at rest. This one moving together and merge and move together now. Now you need to find out the combined velocity. Final. Okay. Don't do it on your regular book. Now try with the scribble paper. If you are trying it on your book, do it with the pencil. Because you might get the correct answer in wrong order. In wrong order. That is why I am really afraid of. You would answer like 40. Uduammu. Hanbi. Yes, Vidu, correct. Others? Yes, Tejaswin. Wonderful, wonder boy. Wonder boy, very good. Okay. In the Newtute, from the page number 30 onward, it is all about momentum. මේක එක අවුලක් වෙලා තියෙනවා මෙයාලා මේ මම හිතන්නේ machine එකේ ink එක run අඩුවෙන් යද්දි ගහලා ඇද්දි they have done it under very low ink level, so some pages were kind of like not printed well. I just told them and they said like they will give me a discount in the next set, but I more than the discount I wanted kind of like quality print. So might be ink was running out of or something. But content is very clear. It should be more beautiful if it was more darker. Okay, have a good look at. So initial condition, you have to write like Pi equals to what? M1 V1. I would write like that, okay? Plus this one. Have a good look at. M2 times 0. And the final. What is it? It is a merge combination M1 plus M2. And the combination is moving at a velocity of V2. Right? Now what can I do? Try to learn like this. Okay? Have a good look at. According to law of conservation of momentum. According to law of conservation of momentum. What is it? P initial should be equals to final. This is what we know. Okay, you have to show like this, right? Then the person who marks your paper knows, wow, this guy knows everything. He's a genius in subject. He has well learned. So you have to give them the impression, you know. So give this one all the time, not in MCQs. If you do an SAO structure, right? It's the according to the law of conservation of momentum. P initial equals to P final. Now what is P initial? This one. M1 V1. And here it is 0, we can cancel off, equals to M1 plus M2 times V2. You can merge these two. Right? Okay. Now have a good look at here. Now I am going to subject V2. V2 equals to M1 V1 divided by M1 plus M2. Try to use these type of expressions rather than numbers, because you have to practice how to use expressions rather than numbers in your future next term test. You will see most of the questions are coming from expressions, and expressions. Okay, M1 is 10. Initial velocity is 4. Now you can substitute M1 plus M2, 10 plus 10. Okay. So it is like 10 times 4 divided by 20. 0 and 0 cancel 2. V2 is just going to be 2 ms minus 1. Mark it. Copy this, copy this. Like this way. Like this way, everything. Okay, Ramai. Enough, ne? You had enough time to copy this. Okay, guys. I will give you another 20 seconds for you to copy this one. Now, okay, Ramai. Now, I think you are ready for something really challenging. Practice. A mass of a mass of 10 kilogram. A 10 among what a mass of 10 kilogram is moving at 4 ms minus 1, velocity of 4 ms minus 1, velocity of 4 ms minus 1, as shown in the diagram. and it collided against a mass of 5 kilogram, which is coming at it collided against with a mass of 5 kilogram, which is coming at it at the velocity of 2 ms minus 1, velocity of 2 ms minus 1, okay, 2 ms minus 1. This is initial. After final, okay. Now, right, in the final condition, if the 10 kg mass is continue to move in, same direction, same initial direction with a velocity of 1.5 ms minus 1. 1.5 ms minus 1. 1.5 ms minus 1. Find out the velocity of 5 kg mass. I mark it like V1, V2, and here like V3, V4. We don't know whether the velocity will go right or to the left. We have no idea. Now try this. This is like a very tricky one. If you understood the concept, law of conservation, oh, you are a killer. You are a killer, Vidusana. Okay. If you understood it, Tejaswin, killer boy. Anik kattiya. Are you lazy? Yeah. If you catch the concept, it is very, very easy. Don't worry. After I explain, you will understand completely. Boy, reconsider. Body awalak tina juttak kau. Others? Come on, boys. Come on. Yes. Fatima, Sanas. Very good. I'm proud of you. Shall I do it now? Honey? Shall I do it now? How would look at? For the initial condition, you have to write what is the initial condition. What is the initial condition? How would look at? P initial is what? M1 V1 in the direction plus M2 V2 in that direction with the negative sign over there. So the V1 will be M1 V1 minus M2 V2 in the same direction. Because I turn this arrow to the other side. So I have to put a negative sign. Vectors. Right. This is the condition number 1. Now for the final condition, the final I will write like M3, sorry, M1 V3 in the right. I know. Plus, I have no idea where it will go, to the right or to the left. No, I don't know. So I will just write like plus M2 V4 to the right. If I get a wrong answer, I get a negative answer because I put to the right arrow. If I hit my answer is not to right, then I will get a negative answer. So this is equation number 2. So you have to add these two, equal these two. Equation number 1 is equals to equation number 2. Have a really good look at M1 V1 minus M2 V2 is equals to M1 V3 plus M2 V4. Now let's substitute the values we know. Value is 10 kilogram. Velocity is 4 minus 5 kilogram. And 2 ms minus 1 equals to M1 is 10 kilogram. V1 is 4 plus M2 is 5. V4, I don't know. So this part, my answer will be 40 minus 10 equals to 40 plus, what is it? 5V. Right. 40 and 40 cancel off from both sides. Then babu vela ande pa ai kiyala. So minus 10 will be remaining here. Wait. It is 30. Oh no. Sorry. It is 1.5. Sorry, my dear, sorry. It is 1.5. 1.5. It is my bad. It is 15. Here it will be remaining 30. Here it is 15. We 15 plus 5V4. When you subtract this here, 30 minus 15 equals to 5V4. V4 equals to 30 over, 15 here. 15 over 5. This is going to be 3ms minus 1. Very easy and simple. Harini? Very easy and simple. Do it. What does he easy. Do it, Lamai. Do it. I'm lazy. I got a positive answer. That means that ball is also moving in the same direction. They're gonna come back there. Okay, lamai. Make a theory නැති කවුරු හරි ඉන්නවා නම් කියන්න. If anybody couldn't understand this, ask me. I will explain you without saying your name. Know that I never say your name when you ask. If you couldn't understand anybody, ask me, I will re-explain. Otherwise, I'll just erase and go for the new one. Okay? Tamai. Yanna? Ayyo. Peroni na yamotum. I think everybody understands this. Hurry. Let's go for the tute. In the tute, there are millions of examples given here. All the important terms are there. Everything is here. What ඕන කරන හැම දෙයක්ම තියෙනවා. There are millions of examples, you see. All examples. Good examples. Good examples. After that, we have simple calculations, intermediate calculations, simple long answer, hard ones, and the past paper questions. Right, lamai. Let's go for one example question. You write that question in your book. Even my physical students today, they had the tute with them. They wrote. Now write this. Two shopping trolleys. Each of mass 12 kilogram. Each of mass 12 kilogram. onna smooth level floor. Smooth level floor. Trolley A is moving at 3.5 ms minus 1. 3.5 ms minus 1. This strikes trolley B. Which is at rest. Okay. After the collision, both trolleys move together in the same direction. Asking in the next, calculate the common velocity of the trolley after the collision. Calculate the common velocity of the trolley after the collision. trolley after the collision. Sorry. I will draw it. There is a one trolley which is moving at 3 ms minus 1, 3.5 ms minus 1. The other trolley is at stationary. Right. Now, after both trolleys merge together and moving with a common velocity of v, that is the question mark. Find it. Find it. An identical trolley, each having a mass of 12 kilogram. 12 kilogram. And the velocity is 0 here. I'm asking the final velocity here. Okay. Yes. I am very, very, very happy. මට ඉතින් කියන්න දේවල් නෑ වචන. Hey boy, no. Here. 1.75 correct. Niloksan correct. Tejasvin correct. Vidusana correct. Pehan correct. Good guys. Good boys. Good boys. Honey, let's do. For the initial condition, Pi, I have to maintain like, I will mark it like M1, here like V1. It is better, huh? M2 and V2. M1, V1 plus M2 times 0. So Pi is only M1, V1 because this is 0. The final is like M1 plus M2 times total velocity of V. I want to equal these two to what is the reason? What is the reason? At low according to the law of conservation of momentum, at low at low M1 V1 equals to M1 plus M2 times V3 V3 equals to M1 V1 over M1 plus M2. So finally, V3 is equals to M1 is going to be 12 times 3.5 divided by 12 plus 12. And 1 and 1. 1 and 1, 2. Finally, I get like 3.5 divided by 2. V3 is 1.75 ms minus 1 to the right. එච්චරයි. අර ලේසි ප්‍රශ්නයක් තා. Okay. Twenty seconds. 20 seconds. I think I gave you enough time. Yes, it is. Because I want to go for a very big topic. We can do it within few seconds. It is obvious, but and theoretically it has a very big value. Right, a big topic: explosions, 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 explosions. Because I am going to be now not Tharudu Priyankara. Instantly, I am turning out to be Osama Priyankara. Okay, because I am going to explode. Ooh. Yes, yes, yes. Real explosiveness going to start. Or you can see me like that Korean dude. What is Kim Jong Un? Tharudu Jong Un, like that. Oh, Velu Pille Tharudu Priyankaran. Velu Pille Tharudu Priyankaran. Okay. Now I'm going to give explosions. Now, right, the theory. Osama bin Priyankaran. Yeah, Osama bin Priyankaran. Okay. Now, right, explosions. Simple theory, explosions. Osama bin Priyankaran. Explosions. Now, right, explosions. Explosions occur in a system. Explosions occur in a system where the initial momentum of the system, is relatively zero, relatively zero to itself object. That is zero according to the objects. Now write this in a new line with a triple star point. At low or according to the law of conservation of momentum. According to the law of conservation of momentum, final momentum should also be what? Tell me, what is the final momentum should be? Zero. Yes, good guys. Zero. How would you get here? Initial, final, dun, dun, dun. Initial, final. Now, right, according to the following system of two masses connected to a spring. Now you apply an external force and bring it together. It is forceful effect. Repel, we just make it together. Once we release, boom. Okay, now draw this one. Then, like here, the spring is inside, you can see. This one has a mass of like m1. This one has a mass of like m2. Velocity of this part is initially 0. Velocity of the other part is also 0. This is m1. This is m2. So P initial is m1 times 0 plus m2 times 0. That means P initial is 0. That is 0. Now let's go for the final condition. You release it. You release it. Actually, after release. After release. අතහැරියට පස්සේ මොකද වෙන්නේ? Now the spring is left alone. M1. M1. It is moving here with V1. Other part is M2. Moving here with V2. So how about it? According to the final condition, it should be also be 0. M1 V1 to here minus M2 V2 to there. This is it. This is how you do explosion related calculations. Do it. Gunfire is also an explosion, no? Bullet has no velocity before, gun has no velocity. So relative to the gun, there is no velocity. When you fire, bullet launches to the forward, gun recoil with back. Gun. Let me show you certain YouTube clip of recoil of a gun. Until you just copy this. You just keep copying. Okay, done. Right, Lamai. Let me share you the thing. Okay, let's see what's happening with this little kid.
Right like that.
Zone safety?
Yeah. Aim before you pull the trigger. Click the safety off. Now aim. Don't put your finger on the trigger until you're aimed. Take.
Got it.
Did you see that? Did you see that? Bullet hits the bullet. So not the bullet. Actually, the gun has hit his chest because gun recoil. How would look at it? That one more time.
Oh, my shoulder.
Good job, buddy. Good shoot.
How do I
Right like that.
Zone safety?
Yeah.
Okay.
Target.
I got him.
Okay, now I'm going to, don't put your finger on the trigger yet. I'm going to take it. Now you're ready to roll as soon as I click this.
Yep.
Now let me put my ears covered because it's going to make a noise. Hold it tight back and shoot.
Whoa, what a kick.
You almost tipped that chair over.
But I didn't miss.
What do you see that? Then you watch these type of videos at home. Then you will be able to see these very wonderful scenarios. So then target World Trade Center. It's slow-mo. You can slow mo, then it will be more clear. Yeah, you can play it at home because everybody has the YouTube facility. After the class, watch many videos of recoil of gun. You will see multiple things, and better to see an animation. There are like very good animations. It shows how the bullet transfer the momentum to the gun and gun recoil. Pistol, it behave like this. It moves up like this. Only in Salman Khan's movies, he look away like this. No, Salman Khan can do like that because there is a physics, there is a fulcrum here. So it will definitely bounce like this. But only for Salman Khan and Tamil Vijay Joseph, they shoot like this. But us can't. There is a proper way of holding. If you hold in the wrong way, you are targeting a certain person, but the victim will be someone else. Okay. Right. Done. Shall we do a real calculation? Okay. Real calculation is going to be, write this in a new line. A new question. Write this. A 5 kilogram gun, 5 kg gun is held stationary and fires a 100-gram bullet. 100-gram bullet at a velocity of fires a 100-gram bullet at a velocity of 200 ms minus 1. Then asking like find the velocity of the gun as it recoils. Recoil වෙද්දි මොකද වෙන්නේ කියලා අහනවා. Right? Sorry. There is an instruction also given here. Use positive sign for any velocity to the acting towards right and negative for any quantity to the left. එක positive right, negative left කියලා මතක තියාගෙන කරන්න. It is as same as of this. I'm not going to erase it. Instead, oh wow. Seriously. Wow. ඔය ඉන්නේ කොල්ලෝ ටික හොඳටම තේරෙනවා. අපි තමයි හොඳටම කරේ. There is the gun, there is the bullet. It is like M1. I will make it like simple M and this one like capital M. Always I use M1 and M2. We can use other symbols as well. Now before, velocity equals to 0. The velocity of this one also equals to 0. V1 equals 0, V2 also equals to 0. Right. After the firing, initial and final. After fire, what would happen here? How would you look at? Gun is there, you don't know, at the mass of capital M. There is a velocity, I don't know. See, bullet is moving with the velocity of mass of 100 grams. Moving in the velocity 100 grams. And the gun of 5 kg. Moving at velocity of 200 ms minus 1. Here I don't know. Okay, I gave you initial instructions. Somebody has done already, no problem. You try taking 2 minutes. Okay, very good, Anwas. Very good boy. Anwas is a good boy. Yan, reconsider. Idusanagre, Akshan, reconsider. Reconsider, boy. You taken it as 150. No, I said like 100. I said 100. That's why your answer got the low one. Okay. Do it. Yes, Pehan, correct. 200 ms minus 1 here. It is 100 grams. 100 gram. I said the values, that is why I didn't write these things in a bigger notation. කියපු දේවල් ටික අපෝ ලොකුට අඳින්න ඕනේ නෑ නේ කියලා කමක් නෑ. You look at my diagram, don't look at my diagram. I just draw it for my satisfaction only. Okay. Another 1 minute more. Quickly. It is exactly same like this. Same scenario for implosions. Implosions 2. Implosions 2. Implosions 2. Now, this is as same mass of this. See, mass of 2 like this. This bullet is like mass 1. It is as same mass of it. No. Mark reading. Here, see. Now the bullet is act as if this one and get done as if act as if this one. It is going to be the same. Okay. Right. No, not 400. Not 400. Oh, visible. Gun එක 400 meters වලින් යනවා. Then you can hold the gun and fire downward and go to the moon. Hold the gun and fire downward. Go to the moon. Have a look. First one, PI. Simple M to the right times V0 plus capital M to the right times 0. So P initial is 0. This is the first condition I can get. Now for the second condition here, final. What is the final condition? Here there is a bullet of simple M moving to the right. P final is, what is it? Simple M multiplied by 200. So let's write like V1 with the here plus capital M times V unknown value V3. Right? Okay, now I can equal these two to here. So P initial equals to P final. According to the condition, what I know. P initial is 0. Final is 100 gram over 1000 multiplied by velocity of 200. Plus, here the mass is 5 kilogram. Multiplied by V, I don't know. 2 zeros gone, 1 0 gone, it is 20. Now I can get the result like here. 0 equals to 20 plus 5V. Now 5V comes to here. Minus 5V equals to 20. V equals to 20 over 5 in the negative. Final velocity is minus, for ms minus 1. Minus 4 ms minus 1. That is it. Understand? Isn't that as same as of this system? මේකමනේ චූටි දේවල් තියෙන්නේ ඔය අමාරුම පාඩම ඔයාලට ඔය එනේ බබා වගේ කියලා දුන්නේ. This is the hardest part you have learned so far, but I explained as if it is in a baby's level. චූටි බබාලට වගේ කියලා දුන්නා. And we did very big questions here. I don't think any of you felt hard. එකෙක්ටවත් අමාරු වුණේ නැනේ. The hardest lesson so far, I'm pretty sure none of you felt it hard today. Did anybody feel hard? අමාරු වෙන්නේ කියන්නේ. This is the hardest lesson. It was that okay to me. අනිවාර්යයෙන් මම ඔය දන්නවනේ අමාරු තැන්වලදී ඔය වගේ බබා වගේ කියලා දෙනවා. But we did very hard questions. You didn't feel the tension. That's it. Right. Tell me whether you need an interval or not. විනාඩි 10ක විතර interval එකක් ඕනේද එපාද? එපා නම් ඕම කරමු ඕන නම් දෙන්න. ටග්ගල කියන්න. Do you need an interval or? Yes please. Don't leave the meeting. Just mute the meeting and go, because after there is a different momentum part and finish this lesson. That is called what? 2D momentum. And you have one relief, because that is not coming in the A-level exam. But in term tests, all the time it comes. ඒ හින්දාට අතරින්න බෑ ටීචර්ස්ලා ටර්ම් ටෙස්ට් වල දාලා දෙනවනේ ටර්ම් ටෙස්ට් වලට අඩුවෙන් ලකුණු ගන්න ආසයි නම් ඉන්ටර්වල් එකෙන් පස්සේ වෙනිදා ගන්න යන්න වැඩි ලකුණු ගන්න ආසයි නම් ඉන්ටර්වල් එකෙන් පස්සේ එන්න හරි interval will be until to like 25 හරි 10 to 25